Hello, ladies and gentlemen. In this video lesson, we're going to be talking about literal equations. Literal equations is just really a fancy way of talking about formulas. We know that we see formulas all the time in math class, in science class, later on when you talk about economics. There's just so many different places where we see formulas. Okay, this sheet should look a lot like the first sheet that you were given in math class. And we're going to just go ahead and follow along and take notes right on here as we go through these notes. So, first of all, the definition of a literal equation. It is an equation with more than one variable. Most formulas that you use in science and math class are literal equations. So for some examples that you might already have seen, an area of a circle is A equals pi r squared. In this formula, we have A standing for area and r standing for radius. So it's an equation that's using multiple variables. Converting temperature from Celsius to Fahrenheit, F equals 9/5 Celsius plus 32. Oftentimes we are asked to rearrange the formula to solve for a different variable. The directions will often read to solve for one variable in terms of the other variables. That's very important, in terms of the other variables. So when you are asked to solve for one of the variables in terms of the other, for example, if we are given h is equal to 2p plus w, we could be asked to solve for p in terms of h and w. This would mean that we need to get the p alone on one side of the equation and the h and w would be on the other side of the equal sign. We use inverse operations just like we do in linear equation solving to accomplish this. Okay, what we're going to do now is go through 4 examples to help us better understand what this literal equation solving is all about. So the first one we're going to look at here is your number 1. If b is equal to 3m plus c, express m in terms of b and c. This means that we want to get the m in this equation alone. So the first thing I want to do is rewrite it so that I can begin to work with it. For this first example, in order for you to kind of get a better idea of what exactly I'm doing, I'm going to also be looking at another linear equation that is a linear equation because it only has one variable, and I'm going to solve that as I am also solving the literal equation. You do not need to write down what I have in red down in your notebook. Okay? It's just to help you kind of understand where it's coming from. So, if I were to look at the equation in red here, and I knew I wanted to solve for m, what would your first step be? And hopefully you're telling me, oh, I would first subtract the 1 from both sides in order to get the 3m by itself. Right? And so let's apply that up above with the literal equation we were given. Okay? I want to get this m by itself. So the first thing I'm going to do is move the plus c. Just like I had to move the plus 1 by doing the inverse operation and subtracting it, I'm going to do the same up here. Now that's going to cancel out on the right-hand side, leaving me just 3m. On the left-hand side, it's a little different. Obviously, when I had two numbers and was subtracting them, I could go ahead and subtract 10 minus 1 and get 9. But over here, when I have two variables subtracting, b minus c is simply b minus c. Okay, back down to the red equation example down at the bottom. I'm now at this step where I have 9 equals 3m. What would the next step be to isolate the m? I would divide by 3. And so I would get 3 is equal to m. Okay, up above, what does that mean I need to do? Well, I think it's fairly obvious. If I want to isolate just the m, I have to divide away the 3 that's attached to it. Now again, what does that mean on the left-hand side? Well, here I have a binomial on the top, b minus c. The whole binomial is being divided by 3. So our answer is b minus c all over 3 is equal to m. You also could write that as m is equal to b minus c all over 3. And that way we have m alone on the one side of the equal sign and the variables b and c on the other side of the equal sign. All right, let's move on and look at number 2. Okay, number 2 is giving us another literal equation. This time it's the volume of a pyramid is equal to 1/3 capital B H, where B is the area of the base and H is the height of the pyramid. Express the H in terms of V and B. So that means I am getting H by itself. Okay, so let's take a look at the operations here that's going on. In the first example, we had addition, which we could undo with subtraction. But I want to take a look at what's happening here. We have V is equal to 1/3 times B times H. And it's this H that I want to try and get by itself. All right, if you notice that everything is multiplying, in general, you would divide to isolate the H. But if one of those terms, if your coefficient here is a fraction, then we're actually going to use our multiply by the reciprocal rule to get rid of that fraction. So just like we did with linear equations, if I have a fraction that I want to get rid of, I'm going to go ahead and multiply both sides by the reciprocal of 1/3, which of course is 3/1. Okay, when I do that, on the left-hand side, I'm going to just have 3V. And on the right-hand side, my 1/3 and my 3 go away, and I get capital B H. Now again, I'm trying to isolate and solve for H. I'm always trying to remember what am I getting by itself. So if I'm trying to get the H by itself, I want to go ahead and divide away the capital B. And so what's left on the left-hand side is 3V over B, and on the right-hand side we have H. And so that is now H in terms of V and B. Okay, we have 2 more examples to get through and then we're all done. All right, the next one says, given that BA squared minus N is equal to V, solve for A in terms of V, B, and N. Okay, so I'm going to start by writing it. BA squared minus N is equal to V. And now I'm solving for A in terms of the other variables, which means I want the A all by itself. Okay, so if there's any addition or subtraction, I want to undo that first if possible. In this case, I'm going to undo the minus N by adding N to both sides. That's going to eliminate the N on the left-hand side, leaving just the BA squared. And on the right-hand side, I'm going to go ahead and add those. Again, they are letters, so when I add them, I cannot get a single answer. I have just the binomial V plus N. Okay, now I am still trying to get the A by itself. But before I can get just A, I have to get A squared. So I first want to uncover that A squared, which means I need to isolate the A squared by dividing away the B. So I'm going to divide by B on both sides, and I get A squared is equal to V plus N, over B. All right, the very last step. Notice that the last thing that I'm undoing is that exponent. If you think about your rules or your order of operation rules that you learned probably last year, usually the first thing that we do is exponents, and the last thing that we do is add and subtract. If you look at how we're attacking these problems, it's in the reverse order. The first thing we're undoing is addition and subtraction, then we undo multiplication, and then we finally undo these exponents. So how is it that I can undo the A squared? Well, the inverse operation to squaring something is taking the square root. So if I want to undo A squared and just make it A, I take the square root of it. The square root of A squared. It's kind of like plus and minus. They cancel each other out. Well, square root and squared cancel each other out and just leave the A. Now, if I do that to the left-hand side, I must do it to the right-hand side. So on the right-hand side, I'm left with the square root of V plus N all over B. We will practice a lot more of those next class, but that's how we're going to attack those squares. Remember, it's the last thing that you do. So that is our answer to get A by itself there. Okay, number 4, last one we're going to look at today. If K minus AM is equal to 3M, express M in terms of K and A. Okay, K minus AM is equal to 3M. All right, as I take a look at this, I'm struck by something that is different than any of the other problems. I notice here that I am asked to solve for M, or get M by itself, but I notice that I have M in a couple places. So that's different. There's more than one M. Well, when that happens, I want those to be on the same side of the equal sign to start off. So the first thing I want to do is move this term, okay, this AM term, I want to get it over with the 3M term. So I'm going to go ahead and move it by adding it to both sides. So I get K is equal to 3M plus AM. All right, now how does that help me? Well, the next thing we want to do is actually, I think what you guys called it last year was reverse distribute or undo the distributive property. If you notice here, we have an M that's existing in both of these terms. It's a common term. We call that a GCF, a greatest common factor term. And we can actually do something called factoring to pull that out, or reverse distribute or undistribute it. So what does that mean? Well, you know, in the distributive property, if I had M times 3 plus A, and I were to distribute that M to both terms, I would end up with, look at what I have right here, I would end up with 3M plus AM. And so that's exactly what I'm doing, is I'm taking this M, this common term, and I'm putting it out front. It's like the step before you would distribute. So I'm going to write this as K is equal to, pull out the M, 3 plus A. And again, if I were to distribute it back in, I should get the line previous to it. Okay? So now I've been able to pull out, now I only have one M. And so now I should be able to isolate that M. What is the operation that's going on between M and this parentheses, 3 plus A? What's going on between the M and the 3 plus A? Well, I would definitely say that they are multiplying. And so to undo multiplication, we of course divide. And we're going to divide by this entire binomial, 3 plus A, to both sides. And so that cancels out on the right-hand side, leaving just my M. On the left-hand side, I have K over 3 plus A. And so M is now by itself in terms of K and A. Okay, ladies and gentlemen, so in this lesson we were able to go through 4 different literal equations, and we were able to rearrange them, and each one of them presented a little bit of a different scenario. So we got to practice 4 very different literal equations. In class next time we will go through and we'll practice a whole bunch of these, as well as a whole bunch of linear equation solving, so that we are just really going to be solid on both of those skills. Thank you so much, and we'll see you next class.